Because the first time I ever saw the video, I was also like, that is a very interesting craft. What is that doing?
So the first thing I want to do is show how easily sensors can be tricked. So let's first start by discussing one of those famous videos, which is the gimbal video. Mick, in that gimbal video, we see an apparently hot object rotating in a bizarre and unphysical fashion. What's your take on what's going on here?
Well, my take is that what we're looking at is something hot, as you say. It's black hot, and that it's essentially something that's so hot that it's causing glare around the object itself. So, for example, if you look at the back of a fighter jet with a thermal camera, depending on the settings and the exposure, if it's overexposed, you're going to get this kind of bright glare around the object. And then I think the shape of that glare is a kind of saucer shaped, but you can kind of see these spikes going at right angles and a little bit at 45 degrees, which kind of indicates diffraction spikes, which is another clue that it's a glare. And then you see this rotation. And I think the rotation is just simply due to the rotation of the camera itself. When a glare shape is going to be relative to some components of the optical system, something along the optical pathway. It could be the aperture, it could be the lens, or it could be dirt on the lens, giving certain diffraction patterns. If you swipe things, you think of a windscreen wiper going, and you see the street lights kind of streak off in certain directions perpendicular to the streaks, that type of thing. And then if something rotates, the orientation of that glare changes. And the camera system is set up in such a way that it has to rotate when it goes left to right because of the kind of limited gimbal system that it has. And then it has to derotate that image to make the horizon at the right angle so it matches what the pilot's seeing when he looks out the window. And the combination of things causes a rotation. I guess that in a nutshell is my gimbal rotating glare hypothesis.
So in effect, what we're seeing is an illusion rather than a physical object rotating in the sky. Ramsey, would you agree with that?
So, certainly an artifact of how the sensors work, yeah, and requires a good understanding of lots of aspects of it. And I think there's a really good, Mick in his previous videos has demonstrated himself that it's possible, and it's nice to have a play with it. So I appreciate it's normally your turn to do this, Mick, but I'm hoping that's coming across well, right? So
that's my bit.
Exactly. So that's this lens in my laptop, isn't it, Mick? That the glare is caused by kind of a feature of that.
And you notice you were rotating the flashlight. Essentially, you were holding the torch, and the shape of the glare itself did not change whilst you were rotating the source of the glare. And that's what happens. It's independent of the object itself. But if you were to rotate your laptop whilst holding your phone steady, which obviously we don't want to do now, it's a bit of a tricky thing, you would see the shape of the glare rotate. So depending on your frame of reference, you either see the glare rotate or you see the background rotate. But basically, they're rotating separate from each other. And that I think essentially is what's happening.
Yeah. I think one of the nice things about it, though, is that it's so easy to conduct an experiment to verify this hypothesis, right? And while we can't get our hands on the actual pod, it's actually really hard to get real data from these things as well. I think it's interesting how quickly we can test a hypothesis that doesn't involve creating an object that can fly through the air and rotate and continue to move in a strange trajectory at the same time. So it's useful that we can quickly verify some of these other methods as being a plausible explanation for what's being seen in the video. Because the first time I ever saw the video, I was also like, that is a very interesting craft. What is that doing? And then, of course, as soon as someone proposes, as you did, that don't forget you're looking at infrared here, and here's an experiment, then everything can click together as being a sensible hypothesis as to what we might be seeing, which, as you said, Sam, could be a more of a trick of the sensors as opposed to a physical object.
And I think the data we did have on screen showed that the camera was in the 3-degree situation where that sort of rotation, so potentially supports that hypothesis. Is that accurate, Mick?
Yeah, it was very near 0 degrees, pointing straight ahead, and that's kind of essentially, it's not exactly a gimbal lock, but it's if you're tracking something from left to right, the way the camera is mounted is that you kind of rotate the camera on its side, and then you use that ball at the end will now be mounted sideways like this, and you can kind of use it to track, but you're going down a little bit, so you can't go past 0 degrees, because then you start going up, so it has to kind of rotate all the way around and go around the other way, and that only really needs to happen in that dramatic manner around 0 degrees. So somewhere around there, the camera system knows that it has to make this move. And it's kind of interesting to delve a little bit deeper into the actual mechanics of the camera itself. We think of these cameras. I have one somewhere. I don't know where I put it, but kind of a pan-tilt zoom camera is kind of so it rotates around, and it's got this up and down thing. It's got kind of 2 axes of freedom, but it doesn't really use those axes all the time for tracking objects. You can think of a security camera tracking someone in a mall. It will rotate around. It's actually got internal gimbals as well, which do the fine-tune tracking, because these pods are very, very large. They're kind of mounted under the plane, and there's the giant things with a big thing on the end. And the pod itself, I believe, weighs about 800 pounds, like literally 800 pounds. And the camera pod at the end itself probably weighs like 50 to 100 pounds. So it's this very large thing that takes a lot of energy, and it's very inaccurate when you move it. So they don't use it for the fine tracking. They have these internal mirrors. So you've got these 2 systems, these 2 layers, one with the very fine tracking, which can move very, very fast. It's just the electro-optical mirrors being moved around by magnets or whatever. And then you've got these giant kind of big balls that weigh many, many pounds that have to be moved by these large geared mechanical driving mechanisms, and that vibrates the entire thing when you do these rotations, and that causes other issues which manifest themselves in the FLIR 1 video for the Nimitz encounter with the Tic Tac. You see it losing lock because it had to make these types of large movements. And so they try to avoid doing it except whenever necessary, which is why you get these large sudden movements instead of like a number of kind of little jerky movements instead.
Makes sense. And the reason I wanted to start with this is because I think it's a good example just to show straight up front how we can fool ourselves, even with very sophisticated technology and with very smart people and good observers looking through that technology. I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.